We're continuing normal distribution. Hopefully, we'll get to conclude the lesson, the topic today, and we'll do a few past papers question as well. Okay, so here's a question. In a statistics examination, %15 of students scored more than 65 marks. Scored more than 65 marks, and 10% of the students scored less than 32 marks. I'm not writing all of it. 10% scored less than 32 marks. Assuming marks are normally distributed, normal distribution bata diya कि this is normal distribution. Find the mean and the standard deviation. Find mean and standard deviation. All right. So we are told that 15% of the students scored more than 65 marks. So we can write it like this. Probability X is greater than 65 equals 15%, which is 0.15. And then we're told that 10% scored less than 32 marks. So probability X is less than 32 is 10%, which is 0.1. Okay. So we have to find the mean and we have to find the standard deviation, which means mean is not 0 and standard deviation is not 1. So we've already discussed that when that's the case, then we need to make the mean 0 and standard deviation 1. How? By subtracting the mean from the value and dividing the standard deviation with the value. Equals 0.15, and probability Z is less than 32 minus mean upon standard deviation equals to 0.1. So now we're going to read the table. See at what value do we get a probability of 0.15? Oh no, we will have to fix that first. Let's fix this. This is greater than, so the table cannot be used for greater than case. It can only be used for the less than case. So we got mean to be 0 now because we subtracted the mean. Okay, so 0.15 probability is going to be somewhere over here. This is 0.15. Yeah. Sorry, 0.15 is a very small probability. Sorry, that is not 0.15. This region could be 0.15. Okay, sorry. Let me repeat again. So there's some value. This value would be represented by the vertical bar. Okay, there's some value, and towards the right side of it, the probability is 0.15. So it should be somewhere over here, 65 minus mu upon standard deviation. It's somewhere over here, and this probability or area is 0.15. Okay. So now what we'll do, we'll instead say probability Z is less than 65 minus mu upon sigma would be, what's the total area under the curve or the total probability? That's 1. 1 minus 0.15. So probability Z is less than 65 minus mu over sigma equals 0.85. Now we can read the table and see for what value do we get the probability of 0.85. Okay. And before we do that, let's also see if we're ready to use this or do we need to fix it a bit. It says probability Z is less than 32 minus mu over sigma is 0.1. So this is 0. This probability is 0.5. So if it's 0.1, that means it's somewhere over here. So this is 32 minus mu upon sigma, and this is the probability or the area of 0.1. Now we cannot use the table for negative values. We can only use the table for positive values. So instead what we'll do, we will move it towards the right hand side, reflect it. So now it will become mu minus 32 over sigma because we are taking its positive value. So if this is a negative value, times it with -1 and get the corresponding positive value over here. So that's why the numerator changes its sign. Now it's mu minus 32 over sigma. And this area or this probability is 0.1. So what we'll do is we'll say probability Z is less than mu minus 32 over sigma should be equals to 1 minus 0.1, which is 0.9. Now we'll read the table and see for what value we get a probability of 0.9. So we're going to use the table and find both these values for 0.85 and for 0.9. Let me quickly cut paste the table. Okay. So 0.85 probability would be, do we have exactly 0.85? No, we have 0.8485. So we have 1.0 here and we have 1.03 here, but we need to change it into 0.85. So what needs to be added to this? 0.8485 has to be changed into 0.85. So what needs to be added here? I'm going to subtract the 2.85 minus 0.8485. We need to add 15. Do we have 15 anywhere over here? No, we don't. But we have 14. So you'll add 14. So the value is going to be 1.136. Sorry, 1.036. So this must be equals to 1.036. When we don't have the exact probability, we settle for anything smaller than it, not a probability bigger than it. That's why we settled for 14 and we did not add 16. Otherwise, the probability would have become greater than what? Than 0.85. Okay, so now we know that 65 minus mu upon sigma should be equals to 1.036. I'm going to call this equation number 1. Now let's see, do we have 0.9 exactly somewhere over here? No. We have this, and in this we'll have to add 3. So we have 1.28, and we need to add 3, Again, we don't have 3 over here, we have 2. So we'll have to settle with 2, and we're going to say that mu minus 32 over sigma should be equals to 1.281. This is equation 2. Now you solve these two equations simultaneously and you get the value of mu and you get the value of sigma. So 65 minus mu equals 1.036 sigma, and mu minus 32 is equals to 1.281 sigma. Now you can make mu the subject in both of the equations and then equate them and get sigma first and plug it in any one of the original values and get mu as well. So you can solve this on your own. I'm just going to give you the final answer that I have with me. Mu would come out to be 50.24 and sigma would come out to be 14.24. So the mean is 50.24 of the distribution and standard deviation is 14.24. Next up is learning how to convert a binomial distribution into normal distribution. That's the last thing we need to discuss in this topic. Okay. So converting binomial distribution to a normal distribution. So we've already discussed that binomial and normal distribution graphically look like this. Normal looks like this and binomial looks like this. Binomial is discrete and normal is continuous. So sometimes the question asks you to change one into the other. All right. Now, this is only possible if certain conditions are satisfied. Binomial to normal is only possible if NP is greater than 5 and NQ is greater than 5. P is the probability of success, Q is the probability of failure, and N is the value given to you in the question. Okay. Okay. So the parameters for binomial distribution are probability X is, let me just write it at the top. So this was probability X equals R equals NCR P R Q N minus R. This used to be the formula for binomial distribution. Okay, so you take N from that, you take P from here as well, and the product should be greater than 5. And similarly, the product of NQ should be greater than 5. If this is true, only then you can apply the conversion, otherwise you can't. Okay. Now the question is, I'm going to teach this to you through an example, that how do we convert? So the related question is a random variable X has binomial distribution with parameters n is equals to 40, p is equals to 0.3. Okay. So see, n is given in the question, p is also given in the question, which means q is also given. Q would be 1 minus p, 0.7. Using a suitable approximation, this word is very, very important. Whenever you see this in a question, that means you have to change binomial into normal. By using a suitable approximation, which you should show is valid. You should show is valid is you must show that this is true, NP is greater than 5, NQ is greater than 5. Okay. Calculate the following. By using a suitable approximation, which you should show is valid, calculate, okay, probability x is greater than equals to 18, probability x is less than 9, probability, this is A, this is B, this is C, probability x is equals to 50. Okay. Now, first let's show that it's valid to use the approximation. So we show that n times p, which is 40 times 0.3, what is this equals to? 40 times 0.3 is equals to 12. 12 is greater than 5. So NP is greater than 5. And then NQ, that's also greater than 5. 28 is greater than 5. So NQ is also greater than 5. So it's appropriate to use this approximation. Okay. So now how do you apply this approximation? Now in this case, it matters if the question says greater than or greater than equals to, because both of the working are different. If the question says greater than equals to, it means something else. If it just says greater than, it means something else. If it says less than, it is something else. And if it says, it means, if it says less than equals to, then it means something else. So all these cases are different. Let me write down all the cases. There's a case probability x is greater than 18. Then probability x is greater than equals to 18. Then probability x is less than 18. And then probability x is less than equals to 18. Okay. So since you're changing binomial into normal, what you have to remember is that you're not going to use this 18. You're going to use its upper bound value or the lower bound value. Let me plot it. Here's a normal distribution whose mean is not 0, by the way, and 18 is, let's say, anywhere on the curve. So there's an upper value for it. There's a lower value for it. Upper is 18.5 and lower is 17.5. So you're not going to be using 18 in any of these questions. You'll either be using 18.5 or you'll be using 17.5. Now, when it says that x is greater than 18, so that means this value. So now you'll use probability x is greater than 18.5. We will be subtracting mean from it. We will be dividing standard deviation with it, but that comes later. Right now, you need to know if it's just 18, if it's just greater than 18, then you use 18.5. Similarly, if it's less than 18, without an equals to sign, then you use 17.5. So that would be probability x is less than 17.5, and later we'll subtract mean and divide standard deviation. Okay. But when it says greater than and equals to, that means that you have to include this entire chunk. So the lower bound also gets selected. So that means this region. It says greater than and equals to. So when it says equals to, this part also is included. So now you're going to change it into probability x is greater than equals to 17.5. And when it says less than and equals to, so again you have to include this side. And less than equals to means this. So now you have to use 18.5. So probability x is less than and equals to 18.5. So all these four cases are different. In this case, it says probability x is greater than and equals to. Now, since it says equals to, this entire chunk gets selected, and we're talking about this region. So that means probability x is greater than and equals to 17.5. Okay, subtract mean from it, divide standard deviation with it. What is mean? What is standard deviation? In normal distribution, we know that mean equals NP and standard deviation equals square root NPQ. So mean comes out to be 40 times P, which is 0.3. So what was this, 12? 40 times 0.3, yes, 12. So we subtract from 12. So we're going to use 12 here instead of mean. And the standard deviation is 40 times 0.3 times 0.7 and square root of that. So 40 times 0.3 times 0.7 is 8.4. So square root of 8.4. Okay. Now subtract 1.8976. Okay, so probability x is greater than or equals to 1.8976. Okay. This must be rounded to 3 decimal places because you read one value from here, one value from here, and one value from here. So you need 3 values after decimal. So this becomes 1.898. Okay. So 1.898, where's that? 1.8 is here. Then 9 is here. So it's this probability. And then add what's under 8, which is 6. So this should be 0.9706 plus 6. So 2 here, 1 carat, 790 here. So 0.9712. अच्छा गलती कर दी. I should have read less than equals to. I've read for greater than equals to. So I need to fix that first. I have to do 1 minus probability x is less than equals to 1.898. So it's going to be, I've read the probability, so I have to subtract 1 from it. 1 minus 0.9712. So this gives 0.0288. That's the answer for part 1. Next was probability x is less than 9. Okay. Probability x is less than 9. Again, we're going to take upper bound or lower bound of 9. Probability x is less than 9. So without subtracting the mean or the dividing the standard deviation, 9 is here, but we're either going to use its upper bound or we're going to use its lower bound. Okay, so less than 9 would mean it's not less than and equals to, so that just means 8.5. So probability x is, z is less than 8.5 minus mean. We had already found the mean of the distribution 12 upon standard deviation, which was square root something. It came out to be 2.8983. Okay, so when we divide this, we get z is less than minus 1.2076. So 3 decimal places, probability z is less than minus 1.208. Okay, it's a negative value, so we need to do a bit of fixing. So negative is somewhere over here, minus 1.208, and it says less than, so we need this probability. Instead, we're going to project it towards the positive side, multiply the value with minus 1, so 1.208. We're going to find this probability from 1 minus probability z is less than 1.208. Now we're going to use the table to see what's the probability for 1.208. So 1.2 is here, 0 is here, so it's this probability, and 8 is here. So we are going to add 15 to the last 2 digits. 0.8849 and add 15. This is what we get, 0.8864. So 1 minus 0.8864, which is 0.1136. Okay. The last part was probability Z is equals to 15. So when it's just 15, we still have to consider the upper and lower bound, 15.5, 14.5. So now what you write is probability Z is between 14.5 and 15.5. Subtract the mean, divide the standard deviation from both of these. So 14.5 minus mean upon the standard deviation, which was 2.8983. 15.5 minus mean upon 2.8983. So it's going to be 0.863, 1.20. Let me do that again. 15.5 minus 12 upon 2.8983. That is 1.207. And I'm going to round it off to three significant figures. So 3 decimal places, 1.208. Okay. So we know what to do here. We're going to use the table. First, find probability C is less than 1.208, and then put a minus sign in between, and then find probability Z is less than 0.863. Okay. So use the table to find the probability for 1.208. Short of time, let me see if I have it here with me somewhere. Yes. So it comes out to be 0.8864 when you read it from table, and the other one comes out to be 0.8059. When you subtract the two, you should get 0.0805. Okay. So we've discussed all that needed to be discussed from the topic of normal distribution. Tomorrow onwards, we're going to do the past papers, inshallah. All right. Take care. See you tomorrow. Allah Hafiz.